This is part 5 of section 5.3. We want to use the information about the given angle between 0 and 2 pi to find the exact value of each of the half angles, sine, cosine, and tangent. Okay, so let's say that we know that sine of theta is 4/5 and that our theta is between pi over 2 and pi, so that means it's in quadrant 2. Okay, so we know our angle is in quadrant 2. This is going to be 5. This is going to be a 4 there. This must be a 3, 4, 5 triangle, so it's going to be -3, 4. So sine is 4/5. Cosine of theta is going to be -3/5. And none of our formulas involve knowing tangent, so I don't need to write that one down. Okay? So sine of pi over 2. Well, if theta is here, okay, sine is positive here and here, so sine is going to be positive. Okay? Actually, if we take half of our angle, and if I take half of this, if I divide each of these by 2, I have pi over 4 is less than theta over 2 is less than pi over 2. So no matter what this angle is, the half angle is between pi over 4 and pi over 2. So that means this is in quadrant 1. In quadrant 1, sine, cosine, and theta are all positive. Okay? So the half angle is going to be positive, sine of the half angle is going to be the positive square root of 1 minus cosine theta. So 1 minus -3/5 divided by 2, and then take the square root of that. So you end up with the square root of 1 minus -3/5 will be 8/5 divided by 2. Which will be the square root of 4/5, which is 2 over the square root of 5. And then when you rationalize that, you get 2 square roots of 5 over 5. And that's the answer they'll be looking for. Okay, for cosine of the half angle, again, it's going to be positive because it's in quadrant 1. And I have 1 plus -3/5 divided by 2. It's the positive square root of that. Well, this will be 2/5, and half of that will be 1/5. So the square root of 1/5, which is 1 over the square root of 5. And then if you rationalize that, you get square root 5 over 5. Okay? And then for tangent of the half angle, you can do sine divided by cosine. You can use any of these formulas if you wish. You'll end up with the same answer. Okay? Now, just to show that to use one of these to show that we don't have to worry about our sines. Okay? So let's use one of these where we don't have the square root and we don't have to figure out which sine we're supposed to be, just to show that we do get the same answer. So let's just do this one. We have sine divided by 1 plus cosine. Okay, so tangent of theta over 2 will be sine of theta, which is 4/5, divided by 1 plus cosine of theta. 1 plus cosine will be -3/5. So I have 4/5 divided by 2/5. So 4/5 times 5 over 2 gives me 2. And if I divided 2 times the square root of 5 over 5 by square root of 5 over 5, I also get 2. You're going to get 2 no matter what there. Okay, so let's do this one. Secant of theta is the square root of 5. That means that cosine of theta is 1 over the square root of 5. Okay. Cosine is positive, sine is positive. That means that we are in quadrant 1. Okay? So that means that theta is between 0 and pi over 2. That means theta over 2, if you divide everything here by a 2, that your half angle is between 0 and pi over 4, which is in quadrant 1, so everything here is positive as well. Okay? Now, to find each of the half angles, knowing your cosine value is enough. You don't need to know your sine value or your tangent value to find any of those. Cosine is enough. So sine of theta over 2 is going to be the square root of, it's going to be positive square root because we're in quadrant 1, 1 minus cosine of theta. So 1 minus 1 over the square root of 5 divided by 2. Okay. Now, if I multiply everything here, top and bottom, by the square root of 5, and I'm multiplying underneath this radical here, I have the square root of the square root of 5 minus 1 over 2 times the square root of 5. Okay? And then if I want to rationalize this, I would multiply, I did this just to get rid of that double fraction there. If I multiply by the square root of 5 again, top and bottom, to rationalize that fraction underneath the radical, I get 5 minus the square root of 5 over 2 times 5, which ends up being the square root of 5 minus the square root of 5 over 10. And this is probably the format they'll want your answer in, although numerically it was the same all along. Okay? Now cosine of theta over 2 is the same thing, but with a plus sign here. Okay? And basically nothing changes on all of these calculations, except this is going to stay where this is a minus sign all the way through. This is going to be a plus sign all the way through. So we have 5 plus the square root of 5 over 10. Okay? Now for tangent of theta over 2, we have this, or if you want to avoid having the square roots in there, and you might want to, then you can go find your sine of theta and do it without that. If we do that, and our original angle was in quadrant 1, this would have been the square root of 5. This is the 0.1 something. To find this, your y value here, it will be 5 squared, or square root of 5 squared minus 1 squared to get a square root of 5 squared is 5. It's 4, so the square root of 4, that must be a 2 right there. So sine, I'm sorry, I didn't realize I was off the screen. Sine of theta is going to be 2 over the square root of 5. Okay, so if I do that, then I have this is equal to 2 times this over the square root of 5 divided by 1 plus cosine. Okay, so this will be equal to 2 times 2 over the square root of 5 divided by, that's going to be the square root of 5 plus 1 over the square root of 5. Okay, which is 2 over the square root of 5 times the square root of 5 over the square root of 5 plus 1. And then if you were asked to rationalize that, you'd multiply top and bottom by the square root of 5 minus 1. You have 2 times the square root of 5 minus 1 over, this is a difference of squares, it's going to be 5 minus 1. So 2 square root times the square root of 5 minus 1 over 4. And you find that this is simply the square root of 5 minus 1 over 2.